Which of the following is equivalent to the expression above? So if you look at the expression up here, we have three terms within that opening set of parentheses, mixture of x's and y's with different powers. We also have three terms within this second set of parentheses. Now, if it's saying which of the following are equivalent to the expression above, we can kind of look at the form that these options are in and hopefully kind of get a hint as to what we're going to have to do. None of these have as many terms as what we started with. None of these have parentheses. So it kind of makes sense to argue that if we get rid of these parentheses and try to combine some like terms, we're hopefully going to be looking at one of these options. And so when you get rid of parentheses, you're just distributing the number outside of them into all of the components of that set of parentheses. So there's a positive 1 in front of this first set of parentheses. When I distribute positive 1 in, and you see these first three terms here, nothing changes. The parentheses just go away. So these are just the same three terms copied down from the first set of parentheses. This is the thing to be careful of. If you're going to mess anything up within a situation like this, it's recognizing that the number in front of the second set of parentheses is really a negative 1. So when you distribute a negative 1 into a negative x squared y, it turns into a positive x squared y. Negative 1 distributed into this positive 3 turns it into a negative 3 in front of the xy squared, and then negative 1 distributed into a negative 3 is going to give us a positive 3 in front of that y squared. Now if you look at this line right here, and you probably recognize this based on the highlighting that I've already done, we have some like terms, right? These pieces are like terms, so if I combine the coefficient 1 in front of x squared y here with another plus 1, I get 2 of those x squared y terms. If you look at the terms that are highlighted in green, I have negative 3y squared, and then I have plus 3y squared at the end. So those are actually going to combine to 0 or cancel for us. Last terms are the ones highlighted in pink. So I have 5xy squared in this position, and I have minus 3xy squared in that position. If I combine a plus 5 and a minus 3, I have plus 2 left. If you look at your options, this is definitely option C. So the last thing we'll talk about before we close out this video is what could have caused you to miss this. Well, I already mentioned one of the things. If you're not careful enough with distributing that negative into that second set of parentheses, you're going to be looking at the wrong option. I think if you did do that, you're looking at choice D. So definitely be careful. Some of the commonly made mistakes are going to be represented within the answer options, so be really, really careful with distributing negatives. The other issue that you could have had here, if you look at the difference between the option that we ended up getting and option A, if you think, well, 2 and 2 is 4, and if I take this exponent and write that out as my answer, you might have potentially gotten option A. I guess one thing that we didn't really mention here that hopefully you're pretty well comfortable with if you're getting ready to take the SAT is what like terms are. Like terms have to have matching variables, and the exponents on those variables have to match. So x squared y and x squared y are like terms. Although this has an x, a y, and also an exponent of 2, notice how it doesn't match the term in yellow immediately to its right, because power 2 is on y in the pink term, and the power 2 is on x in the yellow terms. So the variables and the exponents that are on those variables have to match perfectly. So that would have been another mistake that you could have made here.